start
everyone.
to model.
So, welcome back to our YouTube channel, Becoming a ROS Developer. Today, we've got one of our students, Wen. She has completed the course ROS 2 Basics in using Python. So, she's going to do a demonstration of a project on a real robot, and then we will get into the details about how she managed to accomplish the project. All right, so I will hand over the floor to her, and then she can begin her presentation. So, okay, you can go ahead when.
Oh yeah, I will begin to move the robot. It will rotating to find the nearest wall. Now,
All right, so right now you're trying to get the robot to find the nearest wall before it starts following. Is that right?
oh yes.
Okay,
If it finds the nearest wall, it will begin go forward.
okay,
Oh yes, it's find the nearest wall and begin the wall forward.
okay, okay,
Because I don't have the controller, so it will move left and right.
okay, I see,
It
I see.
yes, exactly to go forward. If it's too close to the wall, it will turn left, and if it's too far to the wall, it will turn right.
All right,
And if it's too close to the front, it will turn fast to turn and pick up. In this process, we can know the position, and we will calculate the current distance.
mm-hmm.
Yes, we can see in the log, we will know the current distance.
All right, all right. So it's keeping track of how far it has gone from the beginning, right?
But yes,
Okay, I see. So you're also using this distance to find when it should stop, or to
oh
so.
yes,
Okay,
uh, one step is is more than 60 three 30 step more, and if the distance is zero, it will close to zero.
okay.
It has a total. Yes. Oh, sorry, because it's not very close to the start position.
Yeah, I see. Because it just went past the starting position and then it didn't stop, right? So, um,
Yes, because the start station is so close to wall, it didn't.
okay, okay. So, how
So
did you mark that point? Can you explain to me how did you mark it as your zeroth point? Did you use some form of coordinate system? How does it know that's the zero? You know.
it will find it will subscribe the odometry. It will know the began position.
Okay, all right. Because, well, I guess if you look at it this way, in the fact that you as your robot goes around the track, right? You take note of the distance that it has gone beyond the, or let's just say you take note of the total distance it is covered, right, around the track. And on the basis of that, you
Yes.
assume that the parameter of your wall, right, is going to be something between 5 and 6 meters, right? And then after that, if you had used a check system to figure out when the distance is gone beyond the total parameter of the wall, you could have managed to make it stop. But in this case, you do realize it failed to stop because it didn't actually get to the point itself because you checked it in that way. But it's fine. I just wanted you to be aware of that method as well of keeping track of the beginning and the end.
Okay. So I think if I larger the tolerance, it will stop.
Oh, okay. I see. Okay, the tolerance of the bounds of your robot, right? Okay, then you to realize I'm in
Yes.
that position again. I see.
Yes. So in this, I think it will stop.
Okay, all right.
So
Yeah, it's fine. Anyway, let's go further and get into the details about how you managed to go through your
okay.
project.
I have one. Yes. My name is Wenhua, and this is the first ROS project, ROS2 project for me, and the goal is find the nearest wall and
Mm-hmm.
approach to the proper distance, do the wall follow and record the odometry.
Mm-hmm.
It is very different between the simulation and the real robot. Now, I print the scan value. We can see the scan header in here, and the angle minimum to the maximum is different between the simulation and the real robot.
Mm-hmm.
So I draw a sketch to determine the right and front index. For the real robot, it's from the negative pi to pi, and the index is from 0 to 720. So the right index is 180. The front index is 360.
Okay.
Uh, yes. And this is the node design. We have 3 nodes and use the service to know if the wall forms, and this is the interface.
Okay.
So
I
if
see.
the yes, the service call, it will give this response and use the action to recording the odometry.
Okay.
And in the action client, it will have the get go callback and the feedback callback and result callback.
Okay.
Through this process, the robot will know if the wall formed, if the first tour has ended. So it will determine uh, if determine the robot to start wall follower or continue or not.
Mm-hmm. Okay.
So yes, uh, this is the logic details about the wall finder. We will calculate the difference between the mean distance index and the front index. So we can know if it's very close to the if it face to the wall, the nearest wall.
Mm-hmm.
If it's not, it will keep rotating, and
Okay.
if it face to the nearest wall, it will uh, uh, want to know if it's close to the wall. If not, it will keep move forward to keep close to the wall to 0.3 meter.
Mm-hmm.
And then if it has to reach to the nearest wall, it will keep turning to keep the nearest wall on the left.
Mm-hmm.
Yes, then it will end the velocity is 0.
I see.
And
I see.
yes, this process then is when began to the wall follower. This is the logic details of the wall follower. Uh, According to the least scan value, if it's larger than 0.5 on the front distance, it will if it's larger than 0.5, it will make a fast left turn.
Oh, okay, I see.
Yes, if the right distance is more than 0.3, it will make a, a slow right turn. And if the right distance is smaller than 0.25, which will make a slow uh, left turn.
All right, so
So
this is like a layered approach to determine how fast it responds, depending on the distance. Is that right?
yes,
All
so
right, I see.
it's a very simple, simple
All right, because
velocity.
I see there's options for hard left turn and then soft left turn. Okay, that's is that what you're trying to explain with this diagram here?
Can you say again?
Are you
What?
saying that the way your robot responds to the rotational angular velocity commands, would it respond faster if it gets too close and respond softer if it is within a certain bounds? Is that what this is?
I calculated the distance between now and uh between this the right distance, and we'll calculate the distance divide the velocity. We'll know the time.
Okay, I see. I see. All right.
Yes.
You can go ahead.
Okay. That's all the details.
Oh,
So
okay.
this is the sum.
All right. All right.
Yeah.
Yeah. Yeah. Let's just go through the summary before I start asking you some questions.
In this process, I use the retrained callback group and the mouse threads executor, so we can let the many callback to examine the parameter, I guess.
Okay.
So this whole process is
All right. I see. And that's all for your presentation.
yes.
All right.
We can see it stopped. Yes.
Finally, it stopped. Okay. Can you check after how long did it stop? Right. Let's see. The distance. Let's see.
Oh, the distance.
Yeah, I want to see the
This is
total
the
distance.
position. Okay. Distance is distance from start is 0.
Okay, so it's actually it almost like started again. Well, at least it recognized that it had gone past the beginning. Okay. Anyway, I have a couple of questions I'd like to ask you. First of all, why did you choose to use re-entrant callback groups? Right. Um, I'm quite fascinated about that choice. Can you please give me some details about it? What led you to
Oh
use
yeah.
them?
I want to. I can see how it. Because there are many callback to execute, and we will start the list scan callback and the service callback.
Mm-hmm.
Uh, we will we will process many values, and I want to if the service we don't let them in the callback group, it will keep a block to wait for the response, right?
All right. So
So yes.
you
So
say
I don't I want to it's don't influence other callbacks process.
okay. So you want to separate the processes, right? You don't want them to interfere with
Yes,
each other.
yes.
Okay, I see. I see. Is there any of because you're using if you're using re-entrant callback groups, right, in multi-threads, that means you basically have got things going concurrently. Is there any threads of the ones that are spun that is to wait for any data from somewhere else, or they're independent of each other, the processes that you're trying to separate?
You mean if we don't use that?
Okay, so your subscription to the scan topic, right, when you are checking
Yes,
if you in the process of your robot checking that has it found a wall or not, right, how does it ensure that it doesn't start moving before finding a wall, right? um
uh, before finding wall
yes.
and how the laser scan to process.
Yes, how does it um if you're spanning it in a separate thread, how do you make it communicate with the other callbacks, right? For example, the callback to start moving and following the wall, right? How are you ensuring that
Yes.
happens? Yes.
Well, okay. Before the I can use the oh sorry, I can use this. Before this is the wall finder process, right? Before the wall follower,
Mm-hmm. Mm-hmm.
and we will use the laser scan callback to know the minimum distance
Mm-hmm. Mm-hmm.
index. Yes, we know the minimum index to use this function.
Mm-hmm.
Yes, minimum. Yes, we know the minimum distance, and we search for the scan value, and we will know the minimum distance. This value's index, and is the minimum distance index. And we will in the scan callback, we will also know the front index and the uh, uh,
Okay.
uh, right index. Yes. So this is all the laser scan callback to do.
Okay. Okay. That's what the scan callback
Yes,
is doing. I see. I see.
yes. And if we know that index, we will to calculate them uh, to know the difference and determine how can we if we rotating or if we keep going forward to find the nearest
Okay. I see. I
to
see.
fit to
Okay.
the nearest and yes,
Mm-hmm. So this is like very hard control, right? It has to check is it gone past the certain index and then stop rotate, or should I keep going forward? So um, but I see why you say that if it used a controller, it would have probably been smoother. But this is good enough. It gets it around, right? That's good. That's good.
yeah.
It I find it that it's more important that you understand the logic of what the control method is doing before implementing it, and this is a clear indication of that. Um, so let me see if I have any more questions here. Your wall finder, right? How do you determine that it has found the wall? Based on the ranges that you're getting, can you explain a little bit how you figure out that this range of laser scan data is the wall itself? Therefore, I have found the wall, or therefore I am parallel to the wall. I can start going. Can you take me through that function itself?
Which function the find wall or forward
Yes,
wall?
yes, the find wall. That's the one that I want.
Okay, this function, right?
Yeah, let's see. Let me see.
Yeah, find the wall. Yeah, I know.
Uh huh.
If yeah. If the distance between the main distance index and the front index is acceptable, it will keep rotating because the angle the velocity is 0.25. Keep rotating and until it's very close and small enough, and mean it has face to the wall
All right. So when that
because
distance is small, then it would know it is it's facing the wall, right?
yes, the minimum distance is close to the front index, so the front is face to the nearest.
Oh, okay, I see. So you're saying if the minimum index is close to the distance on the left or on the right, well, because you're doing following the wall on the left of the wall, right? So it will check the minimum index in the front against the distance on the left, on the right. Is that right?
If the minimum index is close to the right index, it will keep the wall on the right.
And then it will keep moving forward. Is or it will rotate.
Oh yeah, before make the second routine, it will move to determine whether or not move forward.
Okay.
If it's larger than the 0.3, it will the linear speed is 0.05. It will move forward to close to the wall.
Okay. Okay. That's quite good. I get what you were trying to say there. All right. Let me see. Do I have any more questions? No. No, I haven't got any more questions now, and I'd like to say congratulations on your implementation. And I would highly recommend that you explore having to use other type of control methods. This is quite nice because it makes you understand what it has to do, but for future development it would be nice if you try to optimize and get it smoother and smoother. But this is good enough. It shows that there is a detailed understanding of what you want your robot to do, right? So well done on that one.
Yeah, I think so. I will figure out the more control stuff and
Yeah,
make
yeah.
the robot more straightforward.
Yeah, or you could layer it a little bit so that you don't get sudden responses. It's almost like you're doing some proportional control, but just the hard way, right? Having to hard code everything. But if you remember what I spoke about when I was asking you that are you are you determining the speed of the angular velocity based on some metric, and you said no, you were not. Um, because if you say if you realize that the distance of your front index is now too short, right, or you're now too close to the wall, then that requires an immediate um, turn. So your angular velocity is bound to be faster, right? But let's say the distance is slightly bigger, you can start turning, but with a less aggressive angular velocity, right? That's the layered approach I was inkling for.
Yeah,
But yeah, and
yeah,
that's for another time. It's just harder because you have to do everything manually. Whereas if you're using some type of proportional controller, it will be all simpler. Right? All right. So that's it. I would say congratulations, and we will just wrap up our broadcast, and then we can continue our meeting on Zoom. So just hang on a little bit.
okay.
All
Okay.
right.
Thank you.
All right. Okay, so this was Wen's presentation, and I'd like to congratulate her on getting through this one. And it was quite nice. It showed the importance of understanding what the robot has to do in detail before needing to implement a control of some type when there is no actual understanding of what it is doing. So, if you are keen on attempting to get a certification on one of the courses that we offer, we highly recommend you do so. And then you can also come and do a presentation on a real robot, and you demonstrate your understanding by taking us through how you did your project. So until next time, keep pushing your ROS learning. Bye bye.